Okay, guys, so with the second one, because we already did the first one, with the second one, hey guys, up here. Guys. Okay, with the first one, our window was 0 to pi over 2. What fraction of our whole unit circle is 0 to pi over 2?
The left side.
1/4. A quarter, 1 quadrant, 1/4 of it, right? And that gave me half of a circle. So this second one here, if I'm going from pi over 2 to 3 pi over 2, how much of my unit circle is that? Half. So what do you think I'm going to get with my graph? A full circle. So you can plot points if you want to, or you can think about that and go, oh, I know it's going to be the whole thing. It's sine, so what is it going to be centered on? Y-axis, is it going to be up or down? Down, because it's -3. What does the 3 tell me?
Diameter.
Diameter, yeah. So I can just go 1, 2, 3. I know it's going to be attached to the whole. There you go. When you know it's going to be the whole circle, you don't have to plot. Yeah. But if it wasn't going to be the full circle, you'd want to check some points to make sure you graph the correct part of the circle. Yes. Yep. Okay, again, look at the first one. 0 to pi over 2. How much of the unit circle is that? You see it? A quarter of it gives you half of a circle. So half of the unit circle gives you a full circle. If you're graphing 0 to 2 pi, you're actually graphing the same circle twice. Yes. Exactly. This. Again, you can make the table if you need to. That's okay. That's not wrong. You'll get the right point, hopefully. All right, number 3. What is secant? So do you agree that this is 3 over cosine? Okay, so then I could multiply both sides by cosine, and I get r cosine equals 3. What does that mean?
X equals 3.
Yes, x equals 3. So what is that? Line.
I got that one.
Yay! Good job. And again, that's why I didn't give you a window. Windows are weird with the lines, so. Questions on the warm-up? Are we okay? Seems like a lot of people are not okay today.
I'm really good at it.
You're really good. Yes, Henry.
You went over cosine, but I didn't realize you were trying to spray it on.
So, with this, are you okay with these values here? Yeah. Okay, so if I plot 0, -2, or -2, 0, that's this point, right? Okay, and then -1 pi over 3. That means I go left 1, and then my angle's pi over 3. And then 0 pi over 2. This is the whole, so I'm just graphing this half. This does not mean you're going to have a circle in the first quadrant. It means your angles that you're plugging in are between 0 and pi over 2. So if I made a table here, I'd plug in pi over 2. -3 times sine of pi over 2, that'd be -3. So I go -3 pi over 2. And you start working your way around, and you end up all the way back. How hard are you see?
I get it, but it's confusing, but I get it.
Okay.
I know why it's right.
So you just don't like it that it's right? Okay. All right. Let's see. Notes today again are on.
Good job. And not make it. There's some people now. It's better to try out. Look. Are you in the liquid anywhere? Well, next week
They're different. I said they're brainless to stare at this helmet. Monkeys.
Zero.
I don't think it's fair to voice. Just believe now that
Yeah, they're coming. I think. Slowly making its way to you. There we go. All right, guys. So the first one here, do you guys see how this looks different than what we were doing last class? Yeah, what's different about my equation? There's a plus, yes. So we have to figure out what that does to our graph. Yes, the grid is given to you in degrees. You can certainly think through it in radians. I'm going to plug in radians. I don't want to plug in degrees. It's not very fun. We're going to make note of the ratio of A over B. This is A, this is B. So the coefficient on sine is the B. Just the constant out in front is the A. So for this first problem, A over B is equal to 1/3. That means nothing to you yet, but it will eventually. We're just going to jot it down and keep track of it. All right, we're going to graph this from 0 to 2 pi so you can see the whole graph. So I'm going to start by plugging in.
I was like, I can't see it right in the way.
Plug in 0. What do I get if I plug in 0? 1. Okay, it's sine. So do I want to pick pi over 6, pi over 4, or pi over 3? Pi over 6. Why? It's 1/2. I can work with 1/2. I'm still going to get like a half out of it, but yes, it's more reasonable than root 3 over 2. So, yeah. So what do I get when I plug in pi over 6? Not 5 pi over 2, just 5 over 2.
Yeah.
Okay. 5 over 2 or 2.5. Are we okay with that? That's how many rings I'm going to count out, like 2.5. So, okay. What's the sine of pi over 6? Times 3.
Oh,
You're like, nope, that's not there yet. 3/2, then plus 1. Right, I'm just plugging it into this.
So will the 1 ever, will the number ever make it go up and down?
What do you mean?
Like, well, or like a shift up. Yeah.
Well, kind of. I mean, you don't even know what the graph is yet.
Yeah.
So I think you're shifting something that you don't know what it looks like. So let's keep plotting. Okay, guys, I'm gonna pick pi over 2 next. What do I get?
Oh, so you guys have
More. 5 pi over 6. Yep, so 2.5 again. What about pi? 1, because sine of pi is 0. 7 pi over 6. Negative 1/2. How about 3 pi over 2? Negative 2, good. And I know there's not room. Squeeze in 11 pi over 6. What do we get? Negative 1/2 again, okay. All right, we're graphing the whole thing, so I'm going to plot all the points and then connect them with the shape that it is. If you're only graphing a certain window, obviously you would either only pick those points to plot or, graph in the order that it's given to you. Let's make sure we can plot points. I think some people are still struggling when the radius is negative, so make sure we've got this down. So 1, 0. There's my first stop. 2.5 pi over 6. So on that 30-degree line, I'm going to count out 1, 2.5. 4 pi over 2. So that's up where 90 is. Then the 2.5, 5 pi over 6. That's 150 degrees. One pi. All right, now negative 0.5, 7 pi over 6. Where does that end up? It's 30 degrees, right? Yeah, so you're going to go negative 1/2, which is kind of in the middle of that circle, and then around 7 pi over 6. So that's where 30 degrees is. So kind of in there. Do you see it? Like, you start over here. You start at negative 1/2, and then you travel 7 pi over 6. That's right. Okay. Negative 2, 3 pi over 2. Where does that end up? Yes, to the 90 degrees. Good. Okay, then negative 1/2, 11 pi over 6. Where is that? 150. Good. All right, so look at your points. I always think this one looks like a bug, like looking at me when I just have the dot. I don't know. It's like a spider hiding in its web. It won't look like that once we connect. Okay, drawing this. This one is called an inner loop. So let me draw for you and make note. It's very round, like it's almost circular, especially the outside part. And your inner loop will go through the pole. So this is the really roundy part. Then I'm going to cross over, go through the pole, catch that other point, through the pole again, and then back to where I started.
So if we don't draw these perfectly, are you going to take these off?
So I'm not going to be expecting perfection, but guys, let me show you, like, let's say I had these 3 or these 4 points for my inner loop. If your inner loop does this, where it, do you see how that doesn't cross into like this part or this part? That's not right. Okay, it has to cross. I'll show you. I'll show you. Because you go through the pole.
But there's little.
Do you see that? Okay. you know, and then you've got the rest of whatever circle things happening there.
Whenever we do this.
So again, I'm not expecting perfection, but if you don't like hit the points, like if you completely miss them, that's not great. Think of it being round, like spirograph when you were a little kid, that thing that just went around and around in a circle, that's like the feel you should have from these graphs, okay? All right. Oh no, we got lost in the dots. Okay, and it is called an inner loop, INNERLOOP, not interloop, but inner loop. I know the mistakes you're going to make. There's always interesting spelling on these. When I say on the test, label it like limacon and lemniscate. Oh my goodness. That one's coming. I know, I said we should be eating croissants today while we're graphing these. It feels like that. Oh, we should. So guys, a couple things to note. This was a sine equation, right?
Yes.
Does it make sense that it's symmetric on what was the y-axis?
Yes.
Okay. You see everything's positive? The majority of the graph is up.
Yeah.
Okay. Yeah, that's going to matter. If I look at this, what is 1 plus 3? 4. Good job. Do you notice this top point is at 4?
Yeah.
What is the difference between these two? 2. You notice that's how long your inner loop is? Okay. There's some fancy stuff happening, guys. You what? What did you say, Barb?
What about 1/3?
We're going to keep going. We'll reference that in a minute. Okay. That ratio matters. That's how you identify which type of limacon it is. So this ratio was 1/3. Limacon. All right, look at number 2. What's the A over B in this one?
1.
Okay, it is not going to be an inner loop. It is something else. It's a cardioid. Okay, let's plot points. This one's cosine instead of sine. So again, I'll start with 0. What do I get? 4. 2 plus 2, 4. Okay. Do I want to pick pi over 6? No, I will pick pi over 3. 3. Pi over 2. Okay, 2 pi over 3.
3.
Nope. 1. Because cosine of 2 pi over 3 is negative. What about pi? 0. 4 pi over 3.
How much would the next one's -1?
Nope.
Number 1.
3 pi over 2. Noticing a pattern? 2. 5 pi over 3. Squeeze one more in. 3. Okay. It's kind of the same things getting plugged in over and over, like the over 3s. Every time with cosine, you get either a half or negative a half. Okay, so hopefully it shouldn't take much. Yeah, sorry, Ethan, no -1. All right, plot them. This is easier to plot than the last one. Can you see my dots okay?
For some reason, I put my pencil back in a little bit
No, it's going to be like a...
Why is it 0?
Yeah. The kid will do this. forget what a dimple is. Oh, it's been a
It's like when
All right, guys, graphing this. This one is called a cardioid because it is somewhat heart-shaped. It's, again, a very round graph, like very circular. So this part is, you know, kind of just round, and then you come in and you get like the heart-ish. Kind of looks like a lily pad, I think, but Pac-Man. It really should be more curved than I just did these, but that's what you get. All right, so again, type, this is a cardioid. Cardioid. C-A-R-D-I-O-I-D. Cardioid. Cardioid. Ethan, are you okay? This one makes more sense. Oh, okay. No sense. A dimple limacon. All right, A over B. 3 over 2, okay. Make your table here. 0 gives me 5. Pi over 3 gives me 4. Some of you might notice a pattern compared to the last one. 3. 2 pi over 3 gives me 2. Pi gives me 4 pi over 3. 3 pi over 2. And 5 pi over 3. 4. Guys, if you look at your last table, it was also cosine, and it was 2 plus 2 cosine. This is 3 plus 2 cosine. Does it make sense that it's just one bigger all the way through? Okay. All right, I'm going to plot points. Does this graph touch the pole? No. This is our first one that's not going to go through the pole. No, it is still very much polar. This is called dimpled. You're like, and I plotted them, now what? All right, again, graphing very circular-ish with just like a little dip.
Me too.
Like the dimpled and yeah, I don't know. It is interesting. Polars are actually used in, oh gosh, what has to do with like weird things with music, like the way sound comes out of a microphone, different things like that are actually related to polar. I know, they're real. All right, are we okay with our dimpled limacon? Have we accepted that it is not limacon? There's 4. There's one more. All right. Okay, guys. This time, our A over B, what is it? 2. Okay. And we're plotting points. Are we getting better at making a table and plotting? If I plug 0 in, what do I get? 6. Pi over 3. 5. Pi over 2. 4. 2 pi over 3. 3. Pi. 2. 4 pi over 3. We got stuck. What's 3? 3 pi over 2. 4. And then squeeze in 5 pi over 3. 5. We see the pattern, right? Yeah, so it's off your graph. 6 is just somewhere out here. 5, 4, once you have them plotted, we're getting even closer to a circle. This one's called convex. It's like flat on one side. Like if you have a ball and you bounce it on the ground, you know that point of impact, how it just kind of flattens out on one side when it hits the ground? Everyone's seen like slow motion of a ball bouncing, right? No? Maybe not. Okay. That's what the side of it looks like. So the left side is the smushed in slightly part. It's almost kind of just flat over here. Mine looks like it's smushed on more than one side, but bounced off a wall too. I don't know. Okay. So guys, those are your 4 types of limacons. So look at the A over B. What was the A over B when we had interloops? 1/3, less than 1, right? What was it for cardioid? Equal to 1. What about dimple? Between 1 and 2, yeah, and then convex was 2. So the rule is 2 or bigger. So guys, those rules are written out for you down here in this part. Wow, that you can't even see mine up here. At least you have it on your paper. It looks like I just put a box around.
Okay. You can see it.
Okay, tiny bit. Guys, I also think to help me remember like the order they go in, I think of it being like a balloon. So like inner loop is like a balloon that's all just kind of folded in on itself, and then you put a little bit of air in it and it becomes the cardioid shape. A little more air, dimpled, a little more air, convex. Filled completely is actually a circle. The only way a circle happens is when A over B is equal to 0. So what does that mean for A?
There is no.
Yeah, there is no A, which is what we were graphing last time. Okay, so That's just the progression. And it is absolute value of A over B because we can have negative values in there. It could be like 1 minus 3 cosine of A. Okay? That's just going to change the orientation of up and down and things like that. Yes? So if you're graphing the whole thing, sometimes you might not need to. When you're graphing on an interval, you'll probably want to think through some of the points, especially if I give you a weird interval. If I don't give you like 0 to pi, but you know, pi to 3 pi over 2, that's kind of a weird section of it. But just being able to recognize them and which shape it is will help. I could give you matching with some of these graphs. And so being able to pick out like, oh, that's a rose with 7 petals. That's a dimpled limacon. That's a circle. That's a line. Like you have to be able to just see all of those things pretty quickly. Okay. Questions? Okay, we're actually going to do a quizzes as practice. So, partner up.